So galvanic cells are spontaneous. That's the big thing about galvanic cells. They are spontaneous. You'll be learning about another kind of cell called an electrolytic cell, and it is not spontaneous. It has to be forced to go with plugging something into the wall. So that is true that they are spontaneous. It isn't the electrons that flow on the salt bridge. The electrons flow on the wire. So that's what the electrons flow on. The salt bridge, because this is separated, the salt bridge keeps one solution from like slowing down the reaction, but from becoming too positive. And so you don't end up with like a super positively charged and a super negatively charged. Actually, I said that reverse. This would have been super positive. This would have been super negative as the electrons are coming in and the solutions are being used up. And once that starts to happen, you start to have some resistance in a reaction is actually occurring. So as long as we can maintain charge balance, and you'll notice we've been talking about maintaining charge balance when we were doing like solving the oxidation half reduction, those redox when we were balancing them. Notice the last step after we added our electrons, we were adding them in a way so that we had charge balance. And so we need those solutions to have charge balance to make this go. If you didn't have a salt bridge in there, and I know it's not being shown, so assume that there is one, then the reaction isn't going to flow consistently. So the anode gets smaller as the reaction progresses. So if you aren't sure, right here, this is what's going on. The anode is the oxidation. And you'll notice that this guy is slowly going into solution as Y+. Like it's Y neutral as a little chunk of metal, but it's going into solution. So this one is for sure getting smaller. And in contrast, on this one, that's this reaction here. So we've got Z's that are in solution. And as the water travels over, it joins with the Z and it comes up here and it forms Z+. Or some kind of reaction like that. So it's going and it's building on that reaction. So this one would be getting bigger. The cathode's going to get bigger in a galvanic cell. You should know that in all cases, electrons flow from the anode, which is our oxidation, the thing that's releasing electrons, to the cathode, not the cathode to the anode. The anode is negatively charged. It's where all the electrons are. It's the negative pole, and the electrons are attracted over here to the positive pole. So that's why it's going like negative to positive. And then finally, oxidation is at the cathode. Remember, oxidation matches with anode because they are both vowels.